So this is the next lesson in functions. It is function notation, okay, where y is the same as f of x. We mentioned this a little while before. So the old way, we had y equals negative 3x plus 1, but when we're talking about functions, we rewrite it as f of x equals negative 3x plus 1, okay? So this notation right here means f of x, okay? Does not mean f times x, all right? So whatever is inside is your input, okay? So remember, we also call x our input and our y our output, okay? So in the equation, y equals 2x minus 5, identify the variables, and then write in function notation. So if we have f of x equals 2x minus 5, x is your input, f of x is your output. So if I was to change that variable to 2t minus 5, then in function notation, I would use the variable given and write it as function notation. So there are 4 ways to represent a function. There's a table described in words, like a word problem, a graph, as well as an equation. Okay, so given a table, okay, the one that is highlighted here is your input of 9, your output of 13. So for this equation, I would write in function, or this order pair, write in function notation, f of 9 equals 13. So if we had x equals 4 and y equals 6, I would write it f of 4 equals 6. Okay, so anytime we're describing in words and function notation or writing our final answer, it's f of your x value equals your y value. Okay, now in words, when you stop at a gas station, the amount of gasoline in a car's fuel tank in gallons is a function of time in seconds from when the gas pump turns on. So your input is how long, which is your time. Your output is the amount of gas. So how I would write this in function notation, f of time equals amount of gas in gallons. Okay. So then you're represented by a graph. Okay, we did this a little bit the past few days. So the domain here is -4 to 4. Okay. Now, if you see f of 0, that means x equals 0. So what is y? Which would be here. So y would be 0. Okay. F of -2. This means x equals -2. So we go to -2, and we see where the graph intersects, which is at -4. Then this says find x when f of x equals 0. So that means when y equals 0, what is x? So that means these are x-intercepts in this case. So we have x equals -4, x equals 0, and x equals 4. -4, x equals 0, and x equals 4. Okay, so that's when we're evaluating using a graph. And lastly, when you're given an equation, okay, we have the function f of x equals 2x minus 5. Find f of 3, f of -2, and f of x equals 13. So we'll do this one together. So f of 3 means we're substituting 3 in for x. So we have f of 3 equals 1. Okay, then we do the same thing for -2. So we have f of negative 2 equals negative 9. Then the last one, this means y equals 13. So we have 2x minus 5 equals 13. So we add 5 to both sides. We have 2x equals 18. Divide by 2, and x equals 9. So if I was to write this in function notation, f of 9 equals 13. Okay, so we have examples here for you to try. Okay, pause the video and try number 1, A through C, and number 2. Okay, so for number 1, okay, you can either solve it for y equals, or just leave it as is and just input for A 4 and for x. So for A, we should have gotten y equals 18. So in function notation, f of 4 equals 18. Then for B, substitute in negative 1 for x, and we should have gotten y equals 3. So f of negative 1 equals 3. Then in C, f of x equals negative 9. That is your y value. So you plug it into y. So 2 times negative 9 is negative 18 equals 6x plus 12. Then you solve for x, and x equals negative 5. So in function notation, it's f of negative 5 equals negative 9. Okay. Now number 2 is different because we have exponents. Okay. So you're still subbing in 2 for x everywhere you see an x. So we have 2 cubed minus 2 times 2 squared plus 4 times 2 plus 5. Now it's important to have parentheses around what you're inputting because negatives get lost in translation, and that's what you want to focus on first. So 2 cubed equals 8. Then 2 squared gives you 4, so it's 2 times 4 plus 4 times 2 is 8, then plus 5. So when you do this all out, you end up getting 13. So f of 2 equals 13. Now for B, you have a negative input. So negative 3 cubed minus 2 times negative 3 squared. Again, parentheses are key here. Plus 4 times negative 3 plus 5. So negative 3 cubed, that's the same thing as negative 3 times negative 3 times negative 3. That gives you negative 27. Negative 3 squared is positive 9. 4 times negative 3 is negative 12 plus 5. Then you do this all out and you end up getting negative 52 as your answer. So again, function notation, f of negative 3 equals negative 52. Okay. Now in number 3, you are given 2 different equations. So in order to evaluate, you look what's in front, okay, that's the function name. So in A, it says h of 2. So I'm going to use the h function, okay. However, in B, it says b of negative 3. I'm going to use the b function, okay. So those should be pretty straightforward. We're going to go through C and D together, and then you're going to try the rest on your own and check your answers. Okay, so for C, we are using the h function. Okay, so since we are using the h function, we are given an expression to input. Now, we're not giving a value, so if you're inputting an expression, you're going to end up with another expression. Okay, so h of 2a plus 1, we're inputting this whole thing into x. So you have 7 times 2a plus 1 plus 24. Okay, so here we distribute the 7. So we have 14a plus 7 plus 24. Then we combine like terms. So we end up getting 14a plus 31. And that is your answer. That's where you stop. You don't try to solve for A, you leave it as is because you're inputting an expression. So you end up with an expression. Okay, so we're going to try D. Okay, and this is b of 3a, okay, b of 3a, so we use the b function, so it's 2 times 3a squared minus 12. Now, since we have an exponent, okay, you are squaring both terms, the 3 and the a, because they're together through multiplication. So you have 2 times 3 squared, a squared minus 12. You simplify the parentheses, 2 times 9a squared minus 12. Now you multiply 2 times 9a squared is 18a squared minus 12. And that is your answer. Okay, so I want you to pause the video and try the 4 that are left. Okay, you should have gotten the following answers. For A, h of 2 equals 38, because you're inputting 2 for the x of the h function. For B, b of negative 3, you're inputting negative 3. Make sure you have parentheses around it, and you end up with 6. And for E, b of 5, input 5 into the x of the b function, and you end up with 38. And then for F, you have h of 4 minus a. You're inputting that whole expression in for the h function, so you end up with 52 minus 7a. Okay. Now we're getting into combination of functions using operations. Okay, so we have sum and difference in product as well as quotient. Okay, we are going to look at a lot more of adding, subtracting, multiplying, and then eventually composition. So when you have two functions, f of x equals 2x minus 3 and g of x equals x squared minus 1, you are given function notation f plus g of x. That simply means we are adding f of x plus g of x. So we take our two functions, 2x minus 3 plus x squared minus 1. And we combine like terms, and we always write our final answer, highest exponent to your constant. So we have x squared plus 2x minus 4 as our answer. Okay, then we have b, f minus g of x. That's the same of f of x minus g of x. However, around g of x, you want parentheses. So for example, you have 2x minus 3 minus x squared minus 1. The reason you want parentheses around your function when you're subtracting is because you have to distribute the negative sign. So we have 2x minus 3, and distribute the negative sign, negative x squared plus 1. Now we do the same thing, combine like terms and rewrite highest exponent to constant. So negative x squared plus 2x minus 2. Okay, then C is multiplication. It's f of x times, and it's filled in for times, g of x. So you take both functions, f of x, 2x minus 3, and then you have x squared minus 1. And here you are foiling through, okay? So 2x times x squared gives you 2x cubed. 2x times negative 1 is negative 2x. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 2 gives you 3. Now we have to rewrite it from highest exponent to constant. So you're just moving stuff around. You're not adding or subtracting. You're just moving stuff around. So 2x cubed minus 3x squared minus 2x plus 3. And that would be your final answer for multiplying. Okay, so then if it says evaluating, okay, when it says evaluating, you're given a numerical value, okay? You're given a numerical value. The same thing applies in terms of f of x plus g of x. However, now it's going to look like f of 2 plus g of 2. So that means you evaluate f of 2 first and g of 2, then you add them together. So when I do f of 2, I end up getting 2 squared minus 1, so it's 4 minus 1, which is 3, okay? Then I do g of 2, which is 2 plus 4, which is 6. Then I end up adding these two together, okay, which ends up being 9. So you have you end up having f plus g of 2 equals 9. Okay, you could have wrote this as 1, but just to show you how it looks separated, you evaluate f of 2 first, and you get 3, g of 2 next, and you get 6. Add those two together, and you get 9. So for subtraction, we do the same thing. You have f of negative 3 minus g of negative 3. So I will show you what this looks like when you combine them together. So we have f of x equals x squared minus 2. So in this first bracket, I have negative 3 squared minus 1. That's my f of x function, minus x plus 4, so negative 3 plus 4. So I simplify what's in the brackets first. Negative 3 squared minus 1 gives me 9 minus 1 is 8. Then I have negative 3 plus 4 is 1. So I end up with 7. Okay. Now for multiplication, you could do the same thing. Okay. This means f of 0 times g of 0. So you're substituting in 0 for x, for the f function, and then for the g function. So we have f of 0, which means 0 squared minus 1 times 0 plus 4. So we have 0 squared, which is 0, minus 1. So you have negative 1 times 4 equals negative 4. So those are operations of functions, okay? The last thing that we're going to look at is composition of functions, okay? When you're composing two functions together, okay? So the notation looks as follows, and there's two ways you could express this. You have f with this open circle g of x. That's not multiplication, it is composition. So in other words, you see f composed with g of x. Okay, so what this looks like is some ways, a lot of you might find it easier to rewrite it in this notation, okay, because they mean the same thing. So if I see this, f composed of g of x, that's the same thing as f of g of x, okay? So you're probably wondering, well, what does that mean? Whatever's inside the parentheses here is my input. So I'm taking that entire function, so in this case, 4 minus x squared, and inputting it to the x of the f function. So what it looks like is f 4 minus x squared. That's how it would look like in function notation. So what do? I take 4 minus x squared and input it to the x of the f function. So you have 4 minus x squared plus 2. Then you simplify. So here we have negative x squared plus 6 as our function. Okay? So now we look at, it's given to you in a different direction. So we have g composed of f of x, which is g of f of x. So that means I'm now going to take my f function and input it to my g function. So this is what it looks like. We have g of x plus 2. So this is 4 minus x plus 2 squared. Now, since I have that expression squared, we have to expand it out because there's 2 of them. So that means it's going to equal 4 minus x plus 2 times x plus 2. So you have to FOIL that out. So we have 4 minus x squared plus 4x plus 4. Distribute the negative sign. And we have 4 minus x squared minus 4x minus 4. And then you want to combine like terms, and you end up with negative x squared minus 4x as your answer. Okay, so again, when you have an expression squared, you want to expand it out. X plus 2 times x plus 2. Okay, now the other one here is you are going to be composing a function within a function. Okay, so you have g composed with g of x. So that looks like this. So that means we have g 4 minus x squared. So when we input this, you have 4 minus 4 minus x squared squared. Okay, because you're taking this entire function 4 minus x squared and inputting it into the same function. So we have 4 minus, we want to expand this out, 4 minus x squared times 4 minus x squared. Okay, we take care of the brackets first. So we end up getting 16 minus 8x squared plus x to the 4th. We want to distribute the negative sign. So 4 minus 16 plus 8x minus x to the 4th. And we rewrite and combine like terms. We write it from highest exponent. Okay, so we end up getting negative 12 plus 8x minus x to the 4th. Okay, you could actually leave it this way, but if you wanted to rewrite it, and the reason I want you to leave it this way is sometimes the negative signs get lost. So if I rewrite it as negative x squared plus 8x minus 12. This is 8x squared, sorry. Okay, so either one is acceptable. Okay, as long as you have negative 12 plus 8x squared minus x to the 4th, or negative x to the 4th plus 8x squared minus 12. Okay, then if we had to evaluate, okay, functions, you're given a b function and you're given an h function. So if you see b of h of negative 4, that means I have to evaluate h of negative 4 first, get an answer, then take that answer and input it to the b function. So we want to try with h of negative 4 first. So 7 times negative 4 plus 24. Negative 28 plus 24 gives us negative 4. So now I take negative 4 and I'm going to input it into the b function. So b of negative 4 was 2 times negative 4 squared minus 12. 2 times 16 minus 12 gives us 32 minus 12, which is 20. So after going through composition, b of h of negative 4 equals 20. Okay, so pause the video and I want you to try 2, 3, and 4. Okay, You should have gotten the following answers for number 2. You first evaluate b of 3, plug in 3 to the b function, and you end up with 6. Then you take 6 and input it to the h function. So then it's h of 6, so 7 times 6 plus 24. You end up with a final answer of 66. Then 3 and 4 is composing with itself. So you first start with h of -1 and get 17. Then you take 17 and input it back into 7x plus 24, and you end up with 143. Then for number 4, you have b of 2. So input 2 to the b function, and you end up with -4. Then you take -4 and input it again into the b function, and you end up with a final answer of 20. Okay, so we have went through composition, we went through operations, we went through what is function notation. Okay, for 5 and 6, those are compositions of functions like we did above. So you could try those on your own and check your answers on the note key. But, excuse me, if you have any questions, please see me for extra help. But that was the 3rd lesson of the functions unit, okay, with function notation.